Okay, so in this talk we want to update you a little bit about the new features and improvements that we added to our software during the last year. Actually, since the previous conference that we had in Milan last year. I will take care of 3 products, which is ntopConf we are bringing the Unbox UI, the new Unbox UI, and then my colleagues and Ivan will take care of the other products. So let's start with ntopConf. So ntopConf is the application that implements continuous traffic recording. So if you want to record raw packets or pick up data to disk in order to, in case of an incident or for troubleshooting, you want to actually get the real data, the packets, and analyze it with Wireshark. So drill down, for instance, even in ntopng from charts down to flows or alerts, then to the raw data, you need ntopConf. It works like a security camera that 24/7 records the data. So it keeps, like, based on the data retention that you configure, it keeps the last hours or days or weeks. If you consider, for instance, a 10 gigabit link worst case, so with wide rate traffic, you can have up to 4 terabytes of data per hour. So usually, if you have a busy link and you want to record the data using ntopConf, you need a huge disk array if you want to keep hours or even days. You can imagine at 1 gigabit. So over the years, we tried to somehow compress this data in order to save this space and be able to keep more, a larger window, let's say, of time. So we introduced packet compression, which is like gzipping the data, but this doesn't save too much data, especially in internet traffic, which is already compressed. So you can have compressed images, you can have encrypted traffic, which is hard to compress. You can compress more on LAN traffic or in IPv6 trading, for instance. In that case, you can save up to 80–90%, but there are really specific cases. So this doesn't help too much. And it also uses a lot of CPU. We introduced the packet slicing, so in many cases, you want just to keep the packet headers, not the book packets. So in this case, you can specify, hey, I want to store just the packet up to layer 3, layer 4, for instance. Then we have the legacy DPI filters, where you can specify an expression where you say, I want to dump the traffic just for this IP address or subnet and port, for instance. But usually it is useless because you cannot predict which host will be affected by an issue. So you don't know what traffic you want to dump. Something more helpful was introduction of the layer 7 filtering. Here you can decide, I want to dump all the traffic, but I don't know, multimedia traffic, for instance. I don't want to record Netflix traffic, which is taking a lot of disk space, but doesn't help me in case of an issue, security issue, for instance. So this was a good improvement. But we have seen that at 1 gigabit, the traffic is really high. So we wanted to do something better than this. So we came with the idea that not all traffic is alike. So for instance, I have traffic that can be potentially interesting, like HTTP or whatever, so I can filter this by using layer 7 protocol. Filter. But in practice, there is traffic which is really more interesting than the other traffic that requires more priority, which is traffic matching security alerts. So when ntopng, for instance, that implements behavioral checks, detects that there is an anomaly for an host or a specific flow or something, it emits an alert. Or when ntopng receives security alerts from Surigata, for instance, which is an IDS, it emits an alert. So the idea was to prioritize traffic which is matching alerts and discard the rest of the traffic when we feed the disk. So we introduced the smart recording or the smart data retention. This means that we have ntopConf that is recording the data, as I said, using a certain data retention to a first level storage that we call cache. Then this data is somehow filtered based on the events exported by ntopng, so security events, and only selected traffic is moved to a second level storage, the archive. So in this case, our data retention is much larger than in this case. But let's see an example. So let's see how the continuous recording works. So let's say that I start the recording with ntdisk. So I start receiving pickup data. So I receive more data. At some point, I hit my disk limit. So I hit the maximum window size. What happens here? It happens that if I receive more data, so I'm capturing traffic from the network, it starts deleting the oldest data in order to make room for the new one. Like this. Then at some point there is a security event, so something happens in the network. I notice this in ntopng, and I want to analyze this issue. We have seen yesterday in the training that we can go in ntopng, check the alert, and download the pickup file for this issue. So I can drill down up to the packet level. But then this window, which is making our data retention with the new data, moves ahead, and I lose this data. So if I detect I handle this event in a couple of days, and my data retention was just 1 day, I'm no longer able to access this data. So that's why we introduced the smart recording. In the smart recording, I have the cache, which is similar to what we have seen right now. So we receive the data, we start writing to disk, more data, we get the event, okay, we are able to access this data from the cache. So when we go into ntopng and analyze the issue, it happened like 1 hour ago, we are able to access the data here. Then we have this smart recording service, which is moving the data, matching the events to the archive. So what happens is that at some point I'm no longer able to access the data in the cache, but I can still have to access the data matching the events in the archive. So this is the idea. So the data retention is much longer here. But of course, at some point, even the storage has a limited space, so at some point I start deleting the oldest data. But here I have probably days or weeks of time to analyze my issue. So this is what we introduced in ntdisk in the last year. Let's see pfring. So pfring is our packet capture framework. So this is a set of drivers, let's say, that we developed. And it's actually a kernel module for Linux, so it runs just on Linux, plus a library. And we support the packet capture using different level of accelerations. We can capture traffic using standard Linux drivers, up to 2-3 gigabits per second, let's say. We support XDP, which are accelerated Linux drivers developed by the Linux guys, which are faster than the standard drivers, but they don't provide really full rate capture at 10 or more gigabits per second. Then we introduced our zero-copy drivers, which are bypassing the operating system that allow us to capture traffic at a gigabit or even 100 gigabits. We support with those drivers, the zero-copy drivers, adapters from Intel, all the adapter models, and we introduce also support for NVIDIA Mellanox ConnectX adapters. I will show them in the next slides. And we also support specialized adapters from other vendors, which are based on FPGA technologies, which are really optimized for the packet capture. In some cases, they are required, even if we have drivers for Intel or Mellanox. For instance, Napatech, Ethereum, FPGA, and there are other vendors. So this month, a couple of weeks ago, we released the new pfring 8.6. This includes, as I say, new drivers for NVIDIA Mellanox. a new driver for Intel that supports virtual functions, which I will show you later. And of course, we updated the drivers to support the latest Debian Ubuntu kernels. And we introduced also a new component that allows us to push filtering rules on the capture engine at runtime. Because usually, when you run an application, a packet capture application, any application like can be an IDS or one of our application, you can specify a capture filter to monitor selected traffic. But you have to configure them before starting the application because it's an input, it's a parameter. Now we introduce this runtime component that allows you to push filtering rules on demand. And those filtering rules are injected even to the adapter in hardware to be able to cope with 100 gigabits per second. So this is the full list of Intel adapters we support. This year we removed support for MLTK, which is in practice deprecated as adapter and is end of life. It has been replaced by the A10. And we introduced this new driver, the IA-B4, which is the driver supporting virtual functions on the I4E adapters, or Columbiaville, it's the code name. So what's new with this driver? Why is it so interesting? Because when we run a capture on Intel drivers, or Intel adapters, sorry, they allow exclusive access when we run this driver which is a kernel bypass driver. So this means that we cannot run two applications on the same time of the adapter. So we cannot analyze the traffic with them and at the same time record the data with them to disk. With this virtual function driver, which is in practice a virtual function, is let's say we take a device that supports SR IOV and we split a single interface into multiple virtual interfaces. This is used for virtual machines. So with a single adapter, you provide let's say, a network connectivity accelerated in hardware to virtual machines. And those virtual functions support, so they steer the traffic usually based on MAC address or VLAN to the virtual machines, but they also support, not all of them, but in adapters from this family, they support the trust mode that enables slightly promiscuous mode. So what this means that we can configure the adapter with multiple virtual functions, similar to what we do with virtual machine. We enable this trust mode, and this mode, this configuration, we're able to duplicate the traffic. So we can send the same traffic to empty disk and forward. So this was something new with Intel. As I said, we created new drivers also for the NVIDIA Mellanox adapters. They are in the same price range of Intel, so they are commodity adapters. They are, let's say, cheap with respect to specialized adapters. And they are really nice and flexible because, first of all, they are fast. They are able to capture, deliver the traffic up to 100 gigabits per second. They provide hardware timestamps, so for each packet, they are able to give us the stamp with the nanosecond resolution. They allow us to filter the traffic in hardware, so in the adapter itself, saving CPU cycles. We can push a lot of routes, usually 64,000 routes. They can do load balancing and traffic duplication. So we can say, I want to send the same traffic to this for recording and to probe for analysis. And if I want to scale with the performance of 100 gigabit, for instance, I can run multiple instances of a probe and use this offload to hash the packets and distribute the load to multiple application instances. Now, with peer-to-ring, we also contributed over time to the acceleration of IDS systems like Suricata, Zix, or Bro. So at the beginning, we just introduced the support for peer-to-ring in those tools. to accelerate the performance. And of course, we introduced also support for peer-free zero coding. So we were able to deliver 10 gigabit, for instance, line rate capture, because those tools are, let's say, CPU intensive. They use a lot of resources. So we were trying to at least optimize the packet capture side in order to give more CPU to those applications and improve the performance. Actually, accelerating the packet capture side didn't improve a lot the performance of those applications because, as I said, they use a lot of CPU. So that the real problem is that if they have a lot of traffic to process, in most cases, they're not able to keep up with the traffic at high speed. So we tried to add some more optimizations to scale the performance of those tools. So we added the ability to filter traffic at layer 7, so at the application level. Because if you consider internet traffic, for instance, 70% of the traffic is multimedia traffic, like music, video, etc. And it's useless to process this traffic in IDS. So we wanted to reduce the input of those tools to be able to keep up with the traffic rate by discarding all the traffic which is really not interesting, even TLS, for instance. Then, as I said, we introduced in peer-free the ability to push filters at runtime. So we came with the idea of the Suricata and zip on demand. What does it mean? It means that we run the IDS discarding all the traffic in hardware, because we have seen that with the NVIDIA Context adapter we can push filtering rules in the hardware, in the adapter. And we analyze the traffic with other tools like ntopng or at 100 gigabit. We analyze this with ntop, which is sending traffic information to ntopng. In ntopng we have what we call the behavioral checks. So we are able to detect if an host is misbehaving. So he's doing something strange. So the idea is that whenever an host is doing something strange, we push a filtering rule through Redis practice to the capture component running in the IDS, which is in turn pushing a filtering rule to the adapter, which is then sending selected traffic to the IDS. So we are not able to process 1 gigabit per second in the IDS. So the idea is to send just a traffic which is somehow detected as strange. Yeah. Okay. The Unbox UI. So what is the Unbox? The Unbox is this one. So it's an appliance, which is a solution that we build for those who don't want to bother with installing the software because they don't have the skill, they don't have the time, they don't want to select the hardware. So in essence, we provide hardware solutions running our software that can be a box that runs a prop for generating net flow or collecting net flow. It can be a box which is running our ntopdisk for recording the traffic. And they are really optimized and certified by us, let's say, to be able to keep up with line rate even at 100 gigabit or 200 gigabit. Now, in order to manage this box, because we said right now that we build this box for the users which are, let's say, they don't have the skill to build a box. So we don't want even to ask them to configure the software because maybe they are not capable of that. So we provide a user interface, which is a web-based user interface where you can monitor the box, configure the applications, managing the licenses, etc. Now this was our Unbox user interface until last year. Now this is deprecated. We decided to rewrite this from scratch because this had some issues. First of all, it was supported only on Ubuntu systems because it had some dependencies of the operating system. It was based on old technologies. It was using pad-based CGI and legacy HTML templates. It was impossible to extend it for the user if the user wanted to add a page for doing something. It was really complicated. So we decided to rewrite this. So this is the new Unbox user interface, which is based on Cockpit, which is an open source project sponsored by Red Hat, and that supports almost all the Linux distributions, at least the most common ones are supported for sure, like Ubuntu, CentOS, Red Hat. So this is a Cockpit is usually used to manage a Linux box bar image. But this allows us to extend the user interface itself by means of plugins, which are in practice JavaScript stuff. So we decided to take this Cockpit, extend it with plugins using HTTP and Vue.js, which is really simple. So if you want to contribute, it's even easier for the user to contribute. So you can extend it, adding new functionalities. So in practice, you can use this to monitor the box or multiple boxes from a single place, to monitor the CPU, the storage, whatever. Control the applications, so you can configure ntopdisk, nprobe, ntopng, cento, everything, navigate the pickup files. This is an example, so you have ntopdisk, you configure the capture interface, the storage, the data retention, etc. And you can monitor the ntopdisk, which is running, so you see the input traffic, the throughput on disk, etc. This was already available also in the old Unbox, not nice as this, but this was already available. What's new, it's the ability to notify you if something happens on the box. So if there is your colleague which is turning on or off an application, you get notified. If there is a failure, you get notified. If the disk is full, you get notified. So yeah, that's it. So I have my colleagues now that will show you the new features with the other products. Thank you. Any questions?
Okay, hello everyone, I'm Matteo, and we start taking a look instead at ntopng. So let's see, last year what have we done in ntopng? Last year we developed a lot of alerts and checks. If you remember, we had quite an old graphical interface and not quite usable graphical interface regarding alerts and checks. And we decided to renew. We developed even a lot of behavior analysis with behavioral checks that Luca introduced this morning. And we added again support to historical flows and a lot of new integrations. This year, instead, we developed a lot of cybersecurity new features. I've shown mostly all of them yesterday. We developed a lot regarding hidden traffic analysis, so the ability to analyze in the most present way the traffic we have, and we improved instead the historical flows and added a lot of new integrations. Other than that, we even pushed a lot on user interface with the new dashboard that Alfredo has shown, and traffic report and other pages we are going to take a look at. First of all, we added the new model, the XL model, the XL ntopng model. It is able to keep up to 1024 total export with a maximum of 64 network interfaces, and obviously cybersecurity and security features. Let's start with the user interface. This was the user interface of 2 years ago, before the factory. It was nice, but it was not really usable. So we decided to put it anywhere. We decided to totally change the page with the new Vue.js plugin framework. And we decided to do that to enhance a lot, first of all, the performances. We have even 1 year of data downloaded, put in the user interface in less than 2 seconds, even in large networks. And other than that, we have now the possibility, as you can see here, to put even multiple charts, multiple different charts on the same chart. In this way, you can analyze your network in a really better way. So you can first, for example, put the traffic on your interface, and then put the TLS, this custom protocol, and the ntop protocol together to take a look at, for example, how did those protocols perform. Again, from the user interface, we developed the new dashboard. The dashboard that now it is configurable. Currently, you can change all the things you can see in the new dashboard from editing a JSON file. In the next release, we are planning on adding a user from the ntopng user interface, a possibility to add components, so you don't have to just edit the JSON file, but you can do it manually without problems. And in the new dashboard, other than adding the new dashboard, that it depends obviously on the model we have in ntopng. Each model has a different dashboard. It has even the possibility to change between having because enabled or not, so the historical flows. And other than changing the dashboard, we decided to change obviously the traffic report page. Similar to the dashboard, but what do we see in the traffic report? We see historical data, we see historical traffic, application, and so on. Even this is configurable from JSON file. Again, in the next releases, we are planning on having the possibility to change this dashboard from the UI. We added again the possibility with the traffic report to export the traffic reports to an email or whatever you want. You can export this output, currently not in a PDF file, but in a similar format that you can upload and download here on ntopng, so you can take a look at the data at the exact time. And obviously, being configurable means that you have the possibility to have multiple traffic reports that you can change by clicking on the drop-down. You can change the report you want to take a look at. This is an example, for instance, of the email traffic report in ntopng. Instead, if we take a look at the historical flows, we change again here the user interface to be a lot more flexible. Flexible because maybe some people wanted to have specific columns, others wanted to have other specific columns visualized in this user interface. So we added the possibility to change columns, to modify columns, to remove data, and so on. But other than that, we added even a lot of new preset queries, so aggregated information about historical flows. For example, top senders and receiver networks, top sender and receiver countries, the same things goes total system. You can see the full list here. A part of the list, not quite full. And still talking about historical flows, again, similar to what Alfredo told you about ntdisk, we had a similar problem with historical flows. In large network, we had to store a lot of historical flows, a lot of data on the database, on the ClickHouse database. So we thought of a solution to reduce that amount of disk usage. So instead of keeping all the flows, why don't we keep just an aggregation of those data? In this way, we can compact those similar flows. So flows, for example, with the same client, same server, same server port, same application, protocol used, and so on, in order to be able to keep up a lot more data. And now we developed that feature. So you can switch between this normal view of the historical flow, so flow per flow, or the aggregated one. As you can see here, for example, if we take a look at the first flow, it is an aggregation of one flow, but for the second, it is an aggregation of 7 flows. In this way, we reduce a lot the disk usage. In fact, we have from the flows, 99 gigabit of data, we have an aggregation on 600 megabytes. Same data. So we reduced the space used by a lot. We have a compression of data from 2.5 billion flows compressed in 40 million flows. In this way, you can even keep up, for example, 15 days of classic historical flows, so classic flows with all the information, and 90 days of aggregated information. Still talking about historical flows, we decided even to add the possibility, the support to the quick-house clustering. Okay, so now it is possible to have multiple quick-houses, multiple ntopng, sending data to multiple different quick-houses and have all those information, all those data clustered. Like I was saying, we then added a lot more new features and tools to analyze information, security, and network traffic. For example, we added the possibility to have an aggregation again of live flows. In this way, in the flows page, we had the problem that with many flows, it was a bit too hard to explore all those flows. So we decided to aggregate those flows, for example, by translating an application protocol. In that way, it is quite more easy to take a look at the flows and which flow could be a problem. We decided to add a new box to, again, is the possibility to analyze the traffic. So now it's possible, for example, to see that the data is doing traffic towards this IP, using these two applications, and doing traffic towards other hosts using other applications. The same goes for the interface, and the network interface analysis, traffic analysis. So now, for example, in this network interface, it is possible to see that this interface has these different ports, server ports used, connected, with traffic with, using these applications. We even enhanced the map we already had, so now we added the asset map that by using this map it is possible to see the assets you have in the network, so SMP, SMTP, POP, IMAP, the NS server that you have in the network. We added the possibility to take a look at the inactive host. Now, for the first time in ntopng, we keep track of inactive data, so data no more available in the ntopng. We enhanced the service map, so the possibility to see the traffic done between local host and the services used. And now, Nicola will take the microphone.
Okay, so we introduced a new feature. Nice. To, called vulnerability scan to make some analysis on the hosts in a network to find out the vulnerabilities of these hosts and also discover the open ports. And to do that, the user can manually or periodically scan a single or multiple hosts. So here in this page, you can see the host is configured to be scanned by with the periodicity nightly, or just using the schedule all scans button and scan all of the hosts set up to find out the number of CVEs detected and the TCP ports open. And also, it is possible to jump from the actions menu to take many other information, like the show scan report, or download it, or also schedule a periodic scan in a single host. Then show the CVE's details and make scan hosts on specific ports. Here is an example of vulnerability scan report with all of the CVEs detected, and there are the links to jump to the documentation of the specific CVE. These slides, instead, you can see a report of the open ports detected by the vulnerability scan. And for each port, we indicated the CVEs detected, the count of the hosts that have this port, for example, open, and a few lists of the hosts that are details in the port open, in this case. So now, a new feature is the local traffic rules that I mentioned yesterday. So, yeah.
Lo faccio in italiano perché
Vai tranquillo.
volevo chiederti, i vulnerability scan,
Yeah.
come lo fate? Avete sviluppato quel prodotto, avete integrato?
We used the nmap tools. Nmap. Yeah. So, for the local traffic rules, we use this feature to active monitoring the SMP devices, hosts, or network interfaces with periodically check every 5 minutes, 1 hour, or 1 day, configuring a threshold that when it's crossed, trigger an alert. So this is, in this case, a static threshold. Remember, static. In this page, we can see all of the local traffic routes that are set in this moment on ntopng with the metrics, check frequency, and threshold. And here, there's the local traffic routes alert. But there's no slide, afraid. So we have an alert to, no, it's okay, I can do it. There's an alert called unexpected traffic behavior that can detect the traffic made by an interface that is crossing a dynamic threshold set up with the past traffic, okay? And many predictions. So if the actual traffic is crossing the predictions in upper bound or lower bound, the alert is emitted. So there's no.
So differently from this example, the local traffic rules where you set up static threshold, with the other other feature,
Yeah, it's dynamically.
yeah, it is dynamic. So based on the past and the traffic done by that host, interface or whatever it is, we create an algorithm. We have an algorithm that it is able to understand if that traffic is right or not, following its past traffic. Okay?
Thank you. All right. So in the new version, we introduced in ntopng some new integrations with Mattermost, PagerDuty, and Hive. PagerDuty is one of the most commonly used software solutions to notifications management in the States. But the Hive is a well-known platform for managing cybersecurity, alerts, and many other things. Mattermost instead is one of the most used business chat platforms, sponsored by Red Hat. So here in this slide you can see how an alert, when an alert is emitted on or triggered in ntopng, ntopng is sending a notification to the Hive and increment this alert entities counter. Instead, on PagerDuty, we can see all of the details of the alert emitted by ntopng. And when one of them is triggered and PagerDuty receives it, an email was sent to the user. And now an edge. Thank you.
Okay, instead regarding an edge, I don't know if you know about an edge, probably some of you know, but an edge is the ntopng event version. So ntopng that it is able to stop the traffic. Okay? It is in an edge you are able to, for example, define the user application policies. For example, okay, the user A can use, I don't know, up to 1 megabyte of YouTube traffic per day. And you can obviously protect your network from malware and connections because you can stop the traffic, so you can shut down the traffic. And you can even distribute the traffic evenly on the different links you have. Regarding the edge updates, we have some new updates. First of all, we added the support to the multi-LAN. We already had the multi-WAN, but we added even the multi-LAN support. And we added the managing and support for VLANs. Previously, there was no support to VLANs. Now we added the full VLAN support with the ability to add and change and manage all the VLANs from an edge. Other than that, we added the support of the DHCP service, and we improved, first of all, the radius authentication protocol, and we added the radius accounting protocol. So thanks everyone for listening about ntopng features, and now I call Ivan regarding nDPI.
Good afternoon, everyone. I'm going to give you a very quick State of the Union speech about nDPI. No, okay. Oh. Okay. I'm Ivan Nardi, and as far as I know, I'm still working at I2M. I will check later. Okay. nDPI is an open source library that made by ntop that give you two main things. The first one is a deep packet inspection engine that give you network visibility. So protocol classification, metadata, and flow risk extraction. Flow risks are some kind of higher level information. For example, nDPI extracts the TLS certificate, but also tell you if the certificate is self-signed or if it is expired. NDPI extract the HTTP URL, but also tell you if there is a SQL injection in it. That is a SSH traffic, but you also know if the crypto algorithm used are secure or not. That's kind of things. In essence, you have some kind of basic blocks that you can use for any cybersecurity related application. The other things is a quite big set of algorithms for data analysis. So you have data forecasting algorithm, anomaly detection, substring searching algorithms, IP matching, some kind of basic data structure, hash, tree, and something like that. Some probabilistic data structures, so Bloom filters, cardinality estimation, and so on. All of these algorithms are used internally by NDPI to provide its capabilities, but you can also use them directly. I really want to stress out that point because I think that is a little bit unknown. But you can use these algorithms in any kind of application, regardless of the deep packet inspection stuff. They are completely independent. So you can use as you want. Some statistics in the last year, more precisely from the last conference in Milan, we had more than 600 commits in the NDPI made by 24 contributors. Even if you ignore some maintainers and a few ntop employees, I think that those are not bad numbers considering the size of the project. So, what has been done? NDPI is a library. To be useful, you need to build some kind of application around it. So let's see some kind of real application already made that use NDPI or in general DPI library. The most obvious one is to build an application to get some kind of protocol classification or to know what's happening in your network. Luca wrote an article about that a few months ago about ISP, I think, something like that. Another small ISP wanted to know the statistics about its own traffic to YouTube or to Netflix to optimize their peering, or to know if they needed to have a Google global cache locally in their data centers. If you are in line in the network, so if you can change the traffic, you can build any kind of firewall application, so block or allow any kind of traffic. If you have subscriber information, so you are able to match traffic to people, or generally speaking, to subscriber, you can have rules for every user. Block the Facebook traffic for all the students at the university, but allow it for the people in the administration office to allow them to update the Facebook page. You can build some kind of zero rating application. It is usually done by ESP, or any kind of cybersecurity application, ntopng. To have a basic example, where you can have some kind of bandwidth control. So if you want to know who is using all your available bandwidth, you can use this kind of application. Spoiler, it may be your video conference applications. So one VPN provider, you provide a free VPN plan unlimited without any kind of limits on the traffic, but they block BitTorrent traffic. They are using NDPI to do that. Another famous VPN application use nDPI to have some kind of traffic control on the enterprise plans. Last one, active honeypot. A few months ago, some researchers at the Politecnico di Torino published a paper about active honeypot. They studied the incoming traffic. They tried to classify the traffic, to respond to the origin of the traffic, to gather other information. They used nDPI to traffic classification. What has been done in the last year? We added about 50 new protocols, some VPNs, some games, a few streaming services. We had a better performance. We are using less resources, hopefully. We had better testing. Luca spent a lot of time this summer to improve some internal algorithms. Sorry? Okay. And we have some kind of internal statistic about internal data structure. Maintaining a DPI library required a lot of invisible work just to be sure that anything keep working as expected. We very slowly started to have some kind of documentation, but it's a long road. We are very long road. We have a better identification of VoIP and RTP traffic. We have Zoom classification, and we can tell audio from a video stream or some kind of screen sharing. We added more algorithms. We have a better support for customer rules. We have support for nBPF, which is a more simple version of the standard BPF filters that are used in PF3. Correct? We recently added an heuristic to detect fully encrypted traffic. Fully encrypted traffic is that kind of traffic that try to hide themselves, having a network behavior that is very similar to a pure random byte streams. Luca wrote another post about that a few weeks ago, so you can read it about that. And as you may have noticed doing the CTF, there is some kind of basic support for encrypted client law. Encrypted client law is the old encrypted server name features, and it's probably the next big things that will happen in the TLS world. All the major browsers already support encrypted client law. We have detection of gambling sites which are illegal in some countries. Yesterday, Riccardo, yeah, already told you everything about fuzzing and OS fuzz. Fuzzing is basically a testing technique where you check your application behavior when random bytes is used as the input. OS fuzz is a public infrastructure by Google, where open source projects are continuously fuzzed by the Google server. We integrated nDPI in OS fuzz 4 years ago. Last thing, this is a basic ranking that you can find on OS fuzz site. All the projects are ranking according to the most important metrics, which is the runtime code coverage, which tell you basically how much of your code is effectively fuzzed. Okay. it's quite complex to compare different projects because you have projects with 100 line of code, you have other projects with 4 or 5 million line of code. Let's think of White Shark, for example. But according to that metrics, nDPI is basically in the top 10 out of more than 1,000 projects. What does it mean, basically? That we where we is a contributor, are quite good at heading always new and different bugs, but the tools that we are using is even better at detecting them. So nDPI is quite a robust application. What can you expect in the next release? The usual boring stuff, more protocol, better performance, hopefully some kind of configuration, better multi-core support. Some code is already tested, has been already tested to improve BitTorrent and VoIP and VPN traffic. Luca yesterday told about some ideas to integrate machine learning algorithms in nDPI to detect VGR domains. We hope to have a better handling of asymmetric traffic. Asymmetric traffic is that kind of traffic where you have only the uplink packet or the downlink packet. You don't capture both of the links, and that's quite common in the core network of the internet provider. Nothing else. I'm done. Thank you for your time.